Good morning and assalamu alaikum. This is the Light School Nashara campus and it's our chemistry class 9th. Today's topic is ionization energy on page number 76. If you recall last lesson, that was about atomic radii, and today's topic is quite similar to that. So first of all, you have to recall that what were the trends of atomic radii. We said that while coming from top to bottom in a group, the atomic radii increases. The reason is that the number of period increases. That is why their number of shell increases. So when the number of shell increases, here there are one, there is two, there is one, there are two, 1, 2, 3, there are three. In this case, now the fourth period will have how many? 4. And then coming down, so that is 1, 2, 3, 4, and similarly 5th, right? So coming down the group, the atomic radius increases, while going from left to right within a period, the atomic radius decreases because number of electron increases. 2, and if this is, then there will be 3, then there will be 1, 2, 3, 4, and here will be 1, 2, 3, 4, 5. So if you look, the number of electrons increases. What is this? Decreases. What is the reason? The reason is that number of electron increases because nuclear power or nuclear attraction increases, right? So from left to right, atomic radii decreases, and from top to bottom, atomic radii increases, right? The reason for left to right was why it decreases. That is because number of electrons increases, and this increase of number of electron causes the more nuclear attraction. So atomic radius decreases. When the atomic radius decreases, there will be more nuclear attraction over the electrons. And while the atomic radii increases, so look here, the nucleus effect over the valence electron becomes less as compared to the topmost electrons. Here the nuclear effect is more, whereas here the nuclear effect is less. So atomic within a period, within a group from top to bottom, the nuclear attraction decreases, right? Okay, today's lesson is about ionization energy. But before going on there, first there is a concept which should be clear in your mind, that is that an element always want to be stable, and for its stability there are two rules. Rule number 1 is known as duplet rules, which is favored by hydrogen and helium, whereas other elements follow another rule which is called as octet rule, rest of the elements. Okay, what happens in the rule of duplet rule or rule of 2, that the elements like hydrogen and helium, they want to get a complete valence shell of 2 electrons, right? So hydrogen has 1 electron in its valence shell. What will it do? It will try to gain an electron, or it will try to lose this electron, so that it will not have anything, right? It may have an electron or it may lose the electron. But helium, in the case of helium, it has 2 electrons. So we say that yes, helium is stable and helium will not react with any other gas, and that is why helium is belongs to noble gases. In octet rule, the elements wants to complete their valence shell by having 8 electrons. Right? Okay. For example, you are having an element and that element is, just suppose we are having sodium. So sodium have 11 electrons, or its atomic number is 11. This means that how many electrons are in sodium? They are 11. So if we look at the electronic configuration, S, Sp, Spd, let's see if it can be filled. This is first shell, is second shell, this is third shell, right? So 2 electrons will be accommodated here, 2 electrons will be accommodated here, then it's the turn of P, and after that 6. So 6, 7, 8, 9, 10, and 1 electron will be here. Now see, we came to know that in sodium, the valence shell has 1 electron. And according to the octet rule, the elements want to get stability. So for this stability, what will it do? Can it gain 7 more electrons to complete its octet rule to get 8 electrons? Or will it lose this 1 electron, and so 6, 7, 8, it will be completed, right? So in this case, what sodium will do? Sodium will lose an electron. It will lose an electron. And whenever an element loses an electron, it gains the charge of plus. We call it as cation. Right? So the sodium in neutral state, it had 1 electron in its valence shell, and as according to octet rule, the elements want to get stability by having 8 electrons in the valence shell. It will remove, or it will give its 1 electron to something else and will get a positive charge, and will be very happy to get the outermost configuration as 6, and 6 plus 2 is equal to 8 electrons, right? But this process isn't like whatever I wrote. That is okay. But how will it remove the electron? So this sodium atom will require energy for that. Whenever an electron is released, so energy is absorbed. It will need energy to remove an electron, and that energy is called as ionization energy. So how will we identify ionization energy? Ionization energy is the energy which is required to remove an electron completely from the valence shell of a gaseous atom. Right? So, okay. Now if you look at your book, here, sodium in gaseous form, it will need some form of energy, it will make sodium ion plus electrons will be removed. So ionization energy will be equal to, this is plus 496 kilojoule per mole of energy, right? So similarly, magnesium will also need energy to remove one of its electron and will make ion. This ion is known as cation. Now the ionization energy which magnesium required, that is 738 kilojoule per mole. 738, whereas sodium required 496. Can you suggest a reason for it? Sodium required 496 kilojoule per mole energy. Kilojoule per mole is the unit of ionization energy, right? Whereas magnesium required 738 kilojoule per mole energy. So can you suggest any reason for it? Let me help you. Sodium is the member of group 1A. Here, right? Whereas magnesium is the member of group 2A. So sodium has 1 electron in its valence shell. Magnesium has 2 electrons in its valence shell. What happens that we know that nuclear charge, look over here, from left to right, nuclear charge increases. There is more nuclear pull over the element, over the valence shell. So here the nuclear effect or the nuclear pull over the 1 electron is less as compared to magnesium, because magnesium has 2 electrons in the valence shell, right? So let's draw it like this. If this is sodium, so sodium has electronic configuration of, this is first shell, 2 electrons would be here. Second shell has 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. And then the third shell will have 1 electron, right? Whereas by drawing magnesium, magnesium has this 2 electrons. Magnesium has 12 electrons. So 2, then 1, 2, 3, 4, 5, 6, 7, 8. 8, 9, 10. So how many electrons are left? 2 more. 1, 2. So in this case, there are 12 protons. In sodium case, there are 11 protons. So 11 protons have less power over the outermost electron, whereas 12 protons have more power over valence shell electrons, right? So that is why the magnesium is smaller in size. So when it is smaller in size, there is more nuclear charge. So look, the size has an effect. The nuclear charge has also an effect over ionization energies. The more nuclear charge is there, the more energy will it require to remove the valence electron from it, right? So first of all, first electron is removed, then it will get a charge of +1. But now if you look here, the second electron has to also be removed, because it wants to get stability by having 8 electrons. So it will remove the second electron as well. But now if you look here, just count at the electrons. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11 electrons now. But how many protons? 12 protons. So 12 protons have more power than on 11 electrons. In the first case, 12 protons were having power over 12 electrons. But in this case now, in case of magnesium +1, we have 12 protons and 11 electrons. This means there are more positive charges and they will pull these electrons more closer, right? So when they pull these more closer, this means that now we will require approximately double of the energy as compared to make it +1. So let's look here. That is, magnesium required 738 kilojoule per mole of energy to remove 1 electron. But then to remove the second electron from this magnesium ion, the second electron was removed, so it get one other plus charge. So plus and plus, +1 + 1 + 2. Look, that is 738 is approximately double. 7 2s are 14, so 14,050 kilojoule per mole energy was required to remove the second electron from it, right? So ionization energy, this is called as first ionization energy, this is called as second ionization energy, and second ionization energy is always greater as compared to first ionization energy. And if someone asks you about the reason, so the reason would be what? The reason will be that because now more protons, or there is more nuclear attraction, more nuclear force over less electrons, right? Okay, here if you look, that is, it is observed that ionization energies, there is an ant. Okay, it's observed that ionization energies of atoms depend upon several factors. Which factors we observe? We observe atomic radius, we observe nuclear charge, we observe electronic configuration also. But now what is shielding effect? Shielding effect is, let me show you a diagram. That is, where are the groups? Here. Okay. Look, while coming from top to bottom in the group, the number of shells increases, right? So these shells, the more there are shells, the more they will stop, or they will try to stop the nuclear affection. If you remember, we just said that if the shells are less, there will be more nuclear attraction. If there are more shells, there will be less nuclear affection. Why? Because these electrons will not allow the nuclear attraction to go to the outermost shell, because they will get that attraction towards themselves also, right? So the more there are shells, the more there will be shielding effect. So while coming from top to bottom, there will be more shielding effect, which will cause the easy removal of the electron. That is, that the nuclear power is very less over the outermost shell, so the outermost electron can easily be removed. So from top to bottom in a group, ionization energy decreases, whereas from left to right, ionization energy increases. Why do increases? Because nuclear charge increases, right? Okay, so there is look over here. That is, ionization energy for lithium is 520, for beryllium 899, so it's higher. Boron, then carbon, boron is an exceptional case. Carbon is 1086, it's higher. Nitrogen is 1402, that's higher, right? Then there are some exceptional cases as well, but the overall case is that while moving from left to right, what happens? The ionization energy increases. This means that the element will require more energy to remove electron from its valence shell, and the reason is more nuclear charge or more nuclear force over the valence electron. Whereas from top to bottom, if you look, that is 520, 496, 419, 403, so it's continuously decreasing. Why is that? That is because there are more shells, more shielding effect. So and less nuclear force. So if the nuclear force is less, the electron can easily be removed, right? So that's all for today. Please read everything carefully. Read the trends of ionization energies in group and period. I really hope the topic is quite clear to everyone, and have a good day ahead. Thank you very much. Bye bye. Stay home, stay safe.